So this is the fundamental theorem of calculus that you might be familiar with, or at least part of it, right? The integral from a to x of f prime of t dt is equal to f of x, right? Where a, I can add that a is just some constant, right, in the real numbers. Okay. But there's a more generalized form of this that I think is also interesting to look at. And if you're taking AP Calculus, it'll be very useful for you. And pretty much it goes like this. So the integral from a function of x, so one function of x to another function of x, I'm going to call them u of x and v of x, of f prime of t dt, this is going to be equal to f of v of x times v prime of x minus f of u of x times u prime of x. Now you might be like, whoa, that's a lot. But it's really not that bad. Basically, you're going to take, instead of like f of x, it would be f of v of x. So you basically just plug in v of x into here, and then also into here as well. Well, u of x goes in here, and then you just take the derivative of these guys. So if we had, like, for example, let me do an example in blue here. So if we had, so for example, if we had the integral from, I don't know, x to x squared of, I don't know, t cubed dt. Okay, so actually no, this is supposed to be f prime, right? It's gonna be f prime. Wait, yeah, because basically this comes from the chain rule, basically. So so it's gonna be f prime. Hold on. No, it's just f. Right. Yeah, it's going to be f because you're going to be taking the integral of the derivative, which is f. Yeah, okay. All right, so it's just f. So in this case, basically first you need to figure out what the integral of f prime is. So an integral of t cubed is going to be t to the fourth over 4. So we have, so instead of t to the fourth over 4, it's going to be x squared to the fourth over 4. So it's going to be x squared, so it's going to be x to the 8th over 4 times the derivative of x squared, which is 2x, minus, here we're going to have, again, t to the fourth over 4. That's going to be evaluated at x, so it's just going to be x to the fourth over 4 times the derivative of x, which is 1. So really we can just kind of get rid of it, right? So this is what it looks like, right? And the reason why this formula works is because we can basically just say our a, our constant, all the way to x. This is our u of x and our v of x, and I'm just going to say f prime of t dt. Well, that's just going to be f of t, right? But evaluated from actually, hold on. No, because basically we have to think of f of t evaluated at x. So it's going to be f of x times the derivative of x, which is 1, minus f of a times the derivative of a. Well, the derivative of a constant is always 0. So this whole thing goes to 0. And our final answer is just f of x times 1, which is just, f of x, right? So that's where that comes from. And it's pretty easy to show using this formula. And I mean, that's really all there is to it. So yeah, I just basically went through an example of this whole weird formula, introduced this to you, showed an example, and showed why this formula works. Now, you should definitely know this formula because it's a simple one, but it's a special case of this larger example. Now, why don't they teach this whole thing to you? Because it's hard to remember. They teach you this because it's easy. You get your just your basic f of x back. You don't have to worry about this whole weird thing that's going on here. And typically you'll have a constant here on the bottom, so this whole second term just goes away. And really, if you only have a function of x here, you're just gonna have this term. So yeah, that's pretty much all there is to it. So I hope you enjoyed. Thanks for watching. I'll see you in the next video. Bye guys.